everyone. Today I'm going to be talking to you about equivalent ratios, pages 117 and 118 in your Jump Math book. I'm going to start by doing a little review, and I'm actually going to talk about fractions first because it will relate to what we're doing with ratios. I have two fractions on the board here, 1/2 and 3/6. And if you're really familiar with fractions, you will know that 1/2 is equivalent to 3/6. We know that 3 is half of 6, so 1/2 and 3/6 would be equivalent. We've also learned that if we want to change a fraction so that we can see it with the denominator that we're looking for, we multiply. So we would ask ourselves, how do I get from a denominator of 2 to a denominator of 6? Well, I would be multiplying by 3. And then we also know that what we do to the bottom, we must do to the top, which means top gets multiplied by 3. And that's how we get our equivalent fraction. We multiply top and bottom by the same number. So now moving on to ratios. Ratios give a different kind of comparison. So usually you're comparing two things in a set. So in this set we have circles and squares. And if we look and see what we have here, we can see that when we draw this set each time, we're going to see that there are 3 circles for every 2 squares. And if we draw another set of this, we now see 6 circles and 4 squares. Now let's look and see how can we continue the sequence without drawing the set every time. Well, we would look and see how we changed the numbers in the ratio. So the first number here was a 3 and now it is a 6. And the second number was a 2 and now it's a 4. So based on our foundational knowledge of multiplying, we know that to get from 3 to 6 we multiplied by 2. And then same here, we multiplied by 2. So if I wanted to draw a third set, all right, what I would do is go back to my original ratio, and then I would multiply that now by 3 because I've got 3 sets here. So this is going to tell me that for 3 sets, the ratio would be 9 circles, 2, and then it's being multiplied by 3 this time. And then that would make 6 squares. I could keep on doing the sequence starting from my original ratio, and next I would multiply by 4, and then I would multiply by 5, and I would continue that on and on. When you get to page 118, that's exactly what you're going to be doing. You're going to be creating ratios, a sequence of ratios, to solve some word problems. So for example, I have a problem here where there's 5 blue marbles and 2 red. So my ratio is 5 to 2. Okay, and it would like to know how many red marbles would we need if there are 20 blue. So we'd have to find out how many red there would be. What I would be doing is I would be just continuing my sequence until I see that blue is at the number 20. So if there were 2 sets of this, I know that there would then be 10 blues and 4 red. Then if I drew another set, I'd have 15 blue and 6. So we can see that the blues are increasing by 5 each time. The reds are increasing by 2 each time. We can see that from the picture that will be the case. And then finally, there's my 20 blue. And I see that I would be having 8 red. So 8 red marbles in the jar if there are 20 blue marbles. Have fun doing your equivalent ratios today.